This new section, we're going to talk about locus. What is a locus? Well, a locus is a set of points that satisfy a specific condition. Let us see what that means. Suppose you are asked to describe, so one describes the locus, and suppose the problem is, the condition is, it's the set of points 1 inch from the given point P. So here is the given point B. How would you describe the set of points that are 1 inch from the point P? Well, this point is in the set because that distance is 1 inch, and this from P, and this point is on the circle, is in the set because it is 1 inch from P. In fact, all of these points on the circle are 1 inch from P. So the answer is the points, the locus. Actually, how about we say the locus of points? The locus is the points on the circle whose radius is 1 inch and whose center is at point P. So we described the locus or points 1 inch from the point P. It's just a circle. Nothing more, nothing less. But not just any old circle. The center is P, and the points are, and the radius is 1. How would you describe these points? What is the locus or points that are locus of points 3 inches from a circle whose radius is 5 inches. So you're given a circle whose radius from the center is 5. Now, what are the points that are 3 inches away? Well, this point is 3 inches away from the circle. Remember, it has to be the tangent distance. This distance, or this point, is 3 inches away from the circle. This point is exactly 3 inches from the circle. In fact, every point on that circle is 3 inches from the black circle. 5 plus 3 is 8 inches. But the question is, are there any other points that are 3 inches away? And the answer is absolutely. This point is 3 inches away. Sorry. No, this point is 3 inches away from the circle. This point is 3 inches away. This point is 3 inches away. This point is 3 inches away. In fact, all the points on that circle whose center is the same, all 3 circles I drew have the same circle. Okay, so the answer is it's the set of points that lie on the circles whose radii are 8 and 2 inches. So argue why it's 2 inches. Well, if this distance is 5 and that's 3, well then the balance is 2. 8 inches and 2 inches. Set of all points that lie on the circles whose radii are 8 and 2 inches and have the same center as the original circle. Remember, we were given that original circle whose radius was 3 inches. 5 inches. So, once you find one set of points like that outer circle, don't think you're necessarily done. There might be yet some more points. For example, this set of points that are 2 inches from a given line L. So here is the given line L. Which points, if any, are 2 inches from this line? Well, this point is 2 inches. Why? Because that distance is 2. This point is 2 inches. Remember, the distance from a point to a line is not this distance, it's not that distance, it's not this distance, it's the one that meets at a right angle. Okay. So this last distance is 2, and this distance is 2. In fact, all the points on line 1 are 2 inches away from line L. But there's no reason why you can't include this line as well. These the distances between the line L and line 2 are also 2 inches. So it's line L. The locus is the line L1 and L2. They're parallel to line L, and they're 2 inches away. One above, one below. suppose you have a line L, and you have circles tangent to the line L, where the radii are all 5 inches. The centers of all circles of radii 5 inches and tangent to line L. Okay, so you have circles tangent to line L of radius 5. This circle, and this circle, and this one, and that circle, and that circle, and that one, and that one. And we're talking about the centers of all of these circles. What can you tell me about the centers? Well, they all lie on that line. They all lie on that line. And that's the answer. The locus of the centers all lie on this line. Why don't you see your center of a circle right here? Only because I didn't draw it. But every point on this line has a circle of radius 5 that's tangent to line L. This point too. You have a circle on top of the circle. So it's line 1 and line 2. Line 1 is parallel to L, and line 2 is parallel to L, and the points are 5 inches away. The lines are 5 inches apart. That's how you would describe the locus. There are 2 lines parallel to their given line, and they are 5 inches away. You have a nickel, and you have a dime. And you are going to move, you're going to roll a dime around the nickel. That is first the nickel, the dime is here, and then 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 here. You're rolling it around. Okay? You're rolling the dime around the nickel. And the question is, what happened? What's the center points on the center of the nickel? How would you of the dime? How would you describe the center of the dimes as it goes around the nickels? Again, here is the nickel. You have a dime, there's the center. You roll the dime a little bit, and now it's here. You roll it some more, and now it's here. You roll it some more, and it's here. Some more, it's here. But it's always around the nickel. And the locus of points are those points. That's the locus. Here's a different color. That's the locus or points. Now, how would you describe them? Well, it's a circle, and the center of that circle is the center of the nickel. Well, what's the radius? Well, it's the radius of the nickel plus the radius of the dime. Nickel, dime. So that's how you would describe it. It's the circle whose center is at the center of the nickel, whose radius is the radius of the nickel plus the radius of excuse me, of the dime. That's the radius. Okay, so now let us go on to something called compound locus. Actually, let's do this as a separate video.